Hi, everybody. Welcome to AWS Supports You. My name is Chris. I'm based out of Boston. I'm joined today by Gaurav, Arun, and Siddharth. Please, if we can just go around the horn real quick, let everybody know who you are and where you're joining from.
Sure. I'll go first. This is Gaurav. Hey, I'm a technical account manager based out of Delhi, India. And in my role, I work with strategic ISVs to enable them with their ongoing cost optimization, security reviews, and database reviews. I have interests in databases with focus on Aurora and MySQL. Over to you, Arun.
Hey, hi, morning everyone. Thank you for joining AWS Supports You, another episode of AWS Supports You. I'm Arun, solution architect based out of India, and I work primarily for customers in India and help them set up database platform. Today we'll be talking about DocumentDB, its architecture, and some of the best practices. I have with me Siddharth. Over to you, Siddharth.
Thanks, Arun. I'm Siddharth. I'm a technical account manager based out of Delhi. I work with ISV customers and help them achieve operational excellence. Happy to be here talking about DocumentDB cost optimization. And thanks, Chris, for having us on the show.
Of course, happy to have you here. Thank you so much for taking the time, and thank you to our audience for joining us. Like we've introduced already, we're going to be talking about DocumentDB. Of course, we're going to be concentrating on reducing cost and improving performance, as I'm sure you can read. It's right there. But of course, if you have your own questions surrounding DocumentDB, we got a couple of experts with us here today. So please put them into the chat. We will be stopping throughout and addressing those questions, those points. We want to be sure that we're helping you out and supporting you. It's in the title. I will actually be putting a link to our survey over there as well. So you can just let me know how we're doing and what you'd like to see on the show. I do check those. So I would love your feedback. But I don't want to waste too much time up top. I know that we have a lot to cover today. So please take us away and explain what does DocumentDB bring to the table as a managed service, and what are some of the top use cases?
Sure, Chris. I think I'll split into two parts, like what DocumentDB brings on the table as a managed service, and then I'll probably cover when customers should use it, what are the top use cases when customers should consider using DocumentDB. So, DocumentDB is scalable, highly durable, and fully managed service. By that, we mean that it has decoupled storage and compute, and that allows you to scale compute within minutes, regardless of how much data you have in the cluster. When you provision the cluster, you get wide variety of instances from 2 CPU to 96 CPU and 4 GB of RAM to 768 GB of RAM. DocumentDB gives you auto scaling storage, so you don't need to provision or specify the capacity or the IO you want. So DocumentDB takes care of that for your application requirement. And the storage can really go from 10 GB to 64 terabytes. So you don't need to resize your storage of the SAN environment. And again, it's globally distributed, and it supports 15 read replicas. So it really supports millions of reads. DocumentDB is also fully managed, and with fully managed, I mean that there's no hardware to provision. It's a simple setup through console. It gives you built-in availability. So in a click of a button, you have your cluster running in 3 AZs. It also gives you some of the best practices by default. So the backup is enabled by default. The storage in DocumentDB is also highly durable. So every time you store something in DocumentDB, it makes 6 copies across all the 3 AZs. There are a few security best practices which are built into DocumentDB and enabled by default. Like data encryption is enabled by default. As a managed service, it also takes care of the patching and also gives you integration with monitoring services like CloudWatch and CloudTrail and built-in alerting. So that's something that DocumentDB at a high level brings as a managed service on the table. It also is a MongoDB compatible. So, and with compatibility, we mean that it supports the same drivers, tools, and application which you use for MongoDB, and it supports hundreds of APIs and operators which developers use and want them the most. And we work backwards from our developers, so we keep adding more features which our developers use and they want the most. Now, to the second point, where some of the use cases when customers should use DocumentDB. So Chris, now we know that when we talk about microservice architecture, JSON data is the de facto output, and when we use or build microservices, or when we integrate some third-party microservice, DocumentDB really allows us to store and query the JSON data. And another use case could be when you build a new application, you might have a use case where you want to have the flexibility in the schema. Maybe your application will evolve over a period of time. Just to give an example, let's say you build a user preference microservice for a payment gateway. A payment gateway user preference, if you go back in time, we used to have net banking and cards. Now we have wallets and UPI and more payment options. So the preference, there are more attributes that keep getting added as the industry evolves, and you might want to have that flexibility in the application to add more attributes without having to run expensive DDL statements in your large database. And that's where DocumentDB really brings that flexibility of a schema. It also gives you the flexibility of adding ad hoc indexes and running the ad hoc queries. So you don't really need to think the access pattern well in advance. You always have the flexibility to drop and recreate indexes and drop the indexes which are not used. And so that essentially will cover how and when we should do that. And last year, we also used a capability which we call JDBC driver. So DocumentDB also supports where you can connect your visualization tool like Tableau to DocumentDB and can run that operational and analytical workload.
Okay, and touching really quickly on, you were saying there's some support for MongoDB. We did actually get a question from somebody in the audience. It looks like Sandeep Sharma is asking which MongoDB versions are supported by DocumentDB.
Yeah, so DocumentDB currently supports 3.6 and 4.0 Mongo API version.
Okay, cool. So yeah, if you're already using those versions, it looks like you can just get started today with it.
Yeah. And I think, Chris, to also help our audience understand, let's also just dive into the DocumentDB architecture and understand how DocumentDB is more cloud native and what it brings on the table, some of the advantages and the decisions that we made while designing the DocumentDB architecture. So I'd like to, if the time permits, I would like to go through the components in this stack more in the logical way from top to bottom to explain how DocumentDB is different from the monolith architecture and how it is more cloud native. This is a DocumentDB architecture diagram, which I will come back time and again as we build our conversation today. So the first stack in the component is compatibility. So as I mentioned, with compatibility, we mean DocumentDB is MongoDB API compatible. And with that, we mean when you build against DocumentDB, you can expect the same response as you get from MongoDB API. And it supports hundreds of APIs. And with little or no code change, you will be able to start building your application on DocumentDB. Or if you have an application which is already using MongoDB, with little or no code change, you will be able to use DocumentDB as a backend for that application. The second component is separation of compute and storage. And while building the DocumentDB architecture, we really took it as an opportunity and asked if we should really use and make a database with the same way we've been using databases from centuries, or should we really use some of the best practices in the cloud? And we took this opportunity to really build an architecture which leverages the scale of the cloud. So the first thing that we did is the separation of the compute and storage, which makes it really, really powerful. Now, before we talk about that, let's look at the conventional design, which is a monolith architecture. And this is applicable to both relational databases and NoSQL. When you have a monolith architecture, you essentially run the database engine on a virtual machine or as a physical host, where you have all of these operations like API, query processing, caching, logging, and storage. They all sit on one box. It's tightly coupled architecture. Now, and you also have a huge storage attached to it. So depending upon how much data you have in the cluster, you will have a lot of storage attached to it. Now, when you want to scale this, you then will have to copy this entire stack to another machine. And depending upon how much data you have, it can take days or even weeks. The typical challenge that we hear from customers that it is very painful to scale a monolith architecture because of the time it takes to copy. And the customer face the same challenge when they recover from a node failure scenario. So if the node goes down, again, depending upon how much bandwidth you have on the storage, how much throughput you have, or the capacity you have to process, it can take days or even weeks to recover from a node failure. Now, we understand that, and you need to react to your business and may not even have days or weeks. To address this, the first thing that we did is to separate the compute and storage. So some of the heavy lifting is offloaded to the compute layer, which is handling the API request, query processing, and caching, while some of the other work like replication and backup is offloaded to the storage layer. And also to add here, we don't write the full 8K pages. So because sometimes writing the full 8K page becomes a lot. So essentially we push the log writes and the storage layer reconstitutes those pages. Now the reason why we are separating the storage and compute is essentially one, that it helps in break apart the monolith architecture. Two, it also becomes very, very powerful. And I'll cover that later as we build our conversation today. Maybe I think let's talk about some of the scenarios which most of our customers they use, and it really helps, I mean, because of the decoupled architecture that we have. So when you want to start with DocumentDB, you can start a cluster with as small as T3 medium instance. It can be a single node cluster, and I'll talk about it later. But the number of instances in the cluster do not really drive the durability. So you will always have highly durable storage, and you can start building your application. And we also have T3 medium instances, which can really give you that cost optimization while you start developing on DocumentDB. And once you start receiving traffic, you can scale it. So as we see in the animation, from T3 medium, you can go to R5 large or any other instance. And then maybe you can add a high availability to it. So you can horizontally scale it. You can add another read replica. Or maybe you can have a 3-node cluster. You have one primary and 2 read replica. Now, the advantage of decoupled architecture, which is separation of storage and compute, is also that when you horizontally scale, the scaling of compute does not really depend upon the storage. So within minutes, you can add more instances regardless of how much data you have in the storage.
We actually just got a pretty interesting question here from the audience that I wanted to bring up. Can we reduce storage to 0 gigabytes in DocumentDB cluster?
Yeah, so storage we cannot reduce to 0, but DocumentDB definitely manages the storage. So it increases the storage as you add more data, and it also decreases the storage or shrinks the storage as you delete the data. The smallest storage size would be 10 GB. And I'll cover that later as we talk, like how DocumentDB writes to the disk.
Okay.
But storage roughly goes from 10 GB to 64 terabytes.
Okay, cool. So 10 is our bottom level. Good to know. Thank you for the question.
Cool. And then we also have some of the other use cases. So we see customers, they scale up one of the instance, like if they have, and I think Siddharth will cover this as a best practice, that if you have some analytical workload, some different types of access pattern, you can have one of the instance which is larger than the other, and you can run maybe a different type of a use case there. We also see customers scale up their instances in their peak workload, and they scale it back down, essentially because now it doesn't take too much of time to scale up and down, because you essentially do not do anything at the storage layer. You just simply vertically scale your instances, and you can scale them back down. And
right. Arun, we have one more question coming in from our audience. So this is from a user asking if the architecture can also allow for multiple writer instances in a DocumentDB. So can we add more than one primary?
Yeah, that's a good question. So we have another flavor of DocumentDB which we call Elastic Cluster, and that brings the concept of sharding. There we can basically have shards and data being distributed across multiple shards, and essentially we can scale the writes and the reads to millions, and storage can be scaled to petabytes of storage. So there we can have multiple writers for handling different shards. Yeah, so that's an option. It has just launched in this reInvent. So you might want to check out the documentation for DocumentDB Elastic Cluster.
I'm looking that up now. I'll actually put something into the chat to answer that question, hopefully.
Yeah.
Good question. Thanks for asking.
Right. So so I think that one of the important thing or the useful thing about the separation of compute and storage is that the extent is such that you can have a cluster where you can delete all the compute. So this is very useful when you want to optimize the cost in DocumentDB, and that's possible because now they scale independently. So you can have a situation where you just remove all the compute and you still have the highly durable storage. So a use case. So this is one feature that we had last year, where you can start the cluster. And the use case could be that maybe you have a developer environment, you don't want that to use it over the weekend, so you can stop it and start it again back on Monday. Yes, once the cluster is stopped, you cannot query it. So to query it, you need to again add compute to it, and then you can access it. But then it adds a lot of value when it comes to optimizing the cost.
And is that stop and start simple enough? Can it be done through console using
Yeah,
APIs?
yeah, absolutely. It's available through console. You can just go ahead and stop the cluster, and we can start it. Yeah.
Okay. Yeah.
Any other question that we have, Chris, from the audience?
Yeah, we actually just got one from the same user asking, how do we move data from DocumentDB to Data Lake?
Oh, all right. I think there's very detailed answer that I can give, but yes, DocumentDB supports multiple options to move data from data lake. One is we have data migration service, so you can use DMS to move data from DocumentDB to data lake. If you have, and DMS also supports continuous replication, so you can use DMS to have a continuous pipeline from DocumentDB to your data lake. Alternatively, if you have a really large collection with billions of documents, you can alternatively use Glue. So Glue supports dynamic frames and also supports parallel read. So Glue can really move, leverage, or add hundreds of nodes while reading the data from DocumentDB. And it can really add that strength and allow you to copy a lot of data from DocumentDB to a target. However, it is a right fit when you want to do the full load. And you also need to keep in mind that DocumentDB, and Siddharth will cover that, there are a few connection limits and there are a few cursor limits. So you need to provision it accordingly. So when you provision a Glue job, you need to see how much you want to scale Glue, and whatever you configure in the Glue job for scalability, you need to also provision the right amount of connections in the cursor in the DocumentDB. But that's also a very good option if you want to move a lot of data from DocumentDB to your data lake.
Cool. And I went and grabbed a couple of documents there, one for Glue and one for DMS, and put them there into the chat. So hopefully either of those can help you out. And we actually got a question that I know that we're going to be diving into a bit deeper later, so I don't want to take too much time. I know that this is something that, Siddharth, you're going to be covering, but we had a comment here about the IOPS cost was higher than what they'd expected, and they want to know how they can optimize the IO cost. There's information in the barrel. It's coming down.
Yeah, I think maybe we can park this question and I can address this, and maybe Siddharth will address it. We can add a few things here in terms of optimizing the IO cost.
Yeah, for sure. And we actually just got another question. They're coming in hot. Let me just get to it. From Skip John, is it possible to fetch the updated document for an event-driven pipeline?
So if I get the question right, it's possible to fetch the full document. Yes. So DocumentDB supports DocumentDB streams, and when you enable DocumentDB stream, you have an option. You can enable the stream to give you a full document in an update. So yes, if you want to create an event-driven pipeline where you say, okay, if one document it gets updated, I want to consume the full document and I want to trigger some event. Yes, that's possible. So you can use DocumentDB stream. You can fetch full version of the document which gets updated and can consume it in real time.
Okay, and I'm hoping that does answer the question, but if there is a clarification, please let us know. They do have a really quick question coming down right after that one. Does DocumentDB support to store number with decimal data type?
The DocumentDB does, yes. So this is something that we added last year. So DocumentDB supports decimal 128, and that's available.
Awesome. Cool. I'm glad that we have such quick, easy answers off the top of our head. But please feel free to get right back into it.
And I'm also happy to see the audience getting into the mix, right? So please keep the questions coming. I'm sure Arun and Siddharth can take them. If not, we'll definitely try to get the answers to you. So please do keep these questions coming.
Yeah, of course.
Cool. So I think the next, I think, and I hear it from some of my customers that when you have the separation of compute and storage, what happens to the replication? Are there any risks involved? How does the compute know if the data is highly durable on the disk? So I just thought of covering a high level aspects on how the replication works. So one of the advantages of DocumentDB architecture is that now the replication is handled to the storage layer, which means that you free up the instance for more read capacity and query processing. So now the replication is handled by the storage. When you write your data to DocumentDB, you write to the primary instance, and DocumentDB storage layer starts to replicate that to multiple copies in different availability zones, as you see in the animation. The write quorum for DocumentDB is 4. So the moment we have 4 copies available of DocumentDB in the storage, the primary node acknowledges back to the application that the data is durable. Now, what happens next is that the next is primary instance then checks the replica instance and update the replica instance with the latest copy of the data. Not for the durability, but to keep the replica instances updated with the latest copy of the data. Now, if the replica instance do not have the copy of the data, we do not pollute the buffer cache of the replica instance. So we just drop it on the floor. But that also allows the replica instance to manage their own buffer. And so that will cover that, how that is important, and that becomes really powerful because then you can use the replica instances for different use cases. And after that, or in parallel to that, we also create 2 more copies. So we create total 6 copies in 3 availability zones as we write the data. Right? And now we also understand that the replication is handled by the storage layer, and compute essentially gets more headroom or the space to handle more reads and writes. It is, as a best practice, it is also recommended to connect to DocumentDB cluster in a replica set mode and configure a read preference as secondary preferred. This will allow you to handle to scale your reads, and essentially you can do it if your application supports eventual consistency, but definitely it's one of the best practice. So just to show you as an example of the code, while you connect to DocumentDB, you can connect as a replica set mode, and you can define read preference as secondary preferred. Now, also on like what happens if there is any incident, right? So let's just walk through some of these scenarios. So let's say you have a DocumentDB cluster which is available in the 3 AZs, and we we have one of the AZs down, right? This is a very unfortunate and a rare day for us, but let's say that happens, right? DocumentDB has a write quorum is 4 and the read quorum is 3, right? So now, since one of the AZ is not available, we still have 4 copies of the data in another 2 AZs, and we will be able to read, and we will also be able to write because we maintain both the quorum. Now, let's say you also lose 1 copy of the data in one of the AZ. Now, in this case, you lose the write quorum because now you will not be able to write into DocumentDB because write quorum is 4. However, you will still be able to read from DocumentDB. Now, what is important here is to also know that how much time the DocumentDB takes to recover from the incident and how it is different from the monolith architecture. So DocumentDB stores data in the 10 GB segments. So the amount or the time that it requires to recover from the failure is the time it takes to copy the 10 GB data and hydrate another copy from the 10 GB copy. So when you look at the distributed storage, and that's the advantage, right? Distributed storage as against the monolith volume, the mean time to recovery is orders of magnitude faster because it only takes the time which it needs to copy the 10 GB of segment and not the entire volume. And
one moment here, we actually got some comments from the audience that I wanted to bring up. One of them being from Pluperfect TV, saying that first time here. Welcome. Love to have you here. Glad that you're spending your time with us. But we did get a quick question from Core Hacker, which you got to say, love your name. What is the max document size in DocumentDB?
So the max document size DocumentDB is 16 MB.
16 MB. Okay.
Right.
And if you need more information than that, please continue to ask your questions. Love to see the activity in our chat.
Right. So Arun, as you go forward, just a quick thought, right? All this additional work or benefits that we are giving in DocumentDB with the decoupling of storage, does it have any impact on the compute layer at all, or like, uh, is it
In
already
fact,
thought? Yeah,
no,
please.
like I said, two key things, right? One, that we are not writing the full 8K pages, right? So we just send the log writes, and the storage layer reconstitutes those pages, right? So that reduces a lot of traffic between the compute and the storage, because
Right.
sometimes writing the 8K pages becomes a lot. Two, the decoupling the storage and compute also allows the compute to do it gives a little more headroom, because now compute is not taking care of the replication or the durability or the backup. And then
Right.
I think the next is where I'm going to also talk about the backup, because in the backup it also helps, because now when you take the backup, you don't really it is not going to impact your production, because the compute doesn't really participate in backup.
Right.
So
Right.
that,
No, makes sense.
yeah. Yeah, so that's exactly I was about to cover. The backup is also one of my favorites. That DocumentDB provides no impact backup, uh, and it basically allows the backup to be happen directly from the storage. Right. So as you see in the architecture in the diagram, we're not talking about the compute, because compute does not really participate in the backup, and DocumentDB also allows you point in time restore. So 5 minutes ago to 30 days, you can do anytime. You can do a point in time restore, and it also always streams to S3. So, and I think Siddharth will cover that more in the best practices, that how and what are the best practices for the backup.
For sure. We did get another question follow up from Core Hacker that is based around that file size. So if the application has a use case where the document size is going to go beyond 16 megabytes, do you have any recommendations on how they create that data model?
Yes, I think if you think that the application will have a use case where the document will be larger than 16 MB, I think before I talk about, my thoughts on optimizing it, I think we also need to consider, because a larger document size will also create a bottleneck for the application to process that data.
Mm.
Your application will take more time to process a 16 MB or a larger document. All right. So if your endpoint or if your microservice is very sensitive to the latency, then I think you need to consider reducing the document size. However, uh, most times we give this as a best practice to our customers, that if your document size is going big, you can think of dividing that document into two parts, right? Maybe you can have two collections based on the same key. And one of the best practice that you can follow is you can identify your overall from out of your overall attributes, that how many are your dynamically changing attributes versus the static attributes, right? So for example, if you have an order processing application, right, you may have a customer entity where customer name, email address, there are a few attributes which may not change very frequently. You can have them put in one of the collection, where you may have other attributes, which is like the order time, number of orders, anything with the items. You can have that in a different collection, right? So that also allows you to save cost, because you may not be updating the attributes which are not changing. You will only be touching the collection which we have dynamically changing the attributes. So that's how you can think of, instead of one large document, you can think of making two small documents.
Gotcha. Yeah, and I've heard that before as well. I mean, smaller pieces, much faster way for it to actually respond. Um,
Yeah.
I do want to see. I don't know if you'll have an answer to this. I'm not sure if it's a fair comparison, but that is the point of the question. We're being asked by TPM AWS. Would it be fair to say that DocumentDB has almost the same architecture as Aurora?
I think that, yeah, that's not a fair comparison. DocumentDB has its own decisions that we made around, how DocumentDB is more cloud native. So, yeah, definitely, it has a lot of differences when compared with Aurora.
Yeah, I would expect. I know that's probably like a laundry list of us to get into.
Yeah.
So
Right.
I just didn't want to leave it unsaid. I did want to address it as much as we could. And then one last one here we have from Skip John. Can we aggregate using merge objects in DocumentDB?
Yes, merge object is available in DocumentDB. If you're looking to use it in the aggregation pipeline, you can do that. So I think at a merge object and reduce, the two functionalities were launched together in DocumentDB. I think sometime maybe last year or before that. I don't
Okay.
remember, but they are
Sounds like there
available.
was a lot of changes that happened last year.
Yeah.
A lot of these questions are answered with changes we made last year. So that's cool. I'm glad that it's staying dynamic. But why don't we go ahead? Please keep your questions coming, and we will stop when we have opportunities to answer you.
Yeah, I think I would hand it over to Siddharth now. Maybe Siddharth can cover some of the best practices and how we can keep the cost low. Over to you, Siddharth.
Thanks, Arun. Thanks for walking through the DocumentDB architecture. I would like to add here that as customer work to make their applications more cloud native, right? It is important to adopt to the databases which are also cloud native, because without adopting the databases which are cloud native and sticking to the same monolithic architectures doesn't give the application the full benefit of cloud native architecture. So so I'll start talking about some of the best practices with DocumentDB now. Let's begin with the cluster sizing, right? So the vCPU and the memory per instance determine the performance for our cluster, right? So there are certain best practices around choosing the size, and we have a wide range of instances to choose from. uh, which instance we should choose, and we should start that by asking ourselves that how much is the working set we have, right? How much of the data and how much the indexes we want to store in the cache. And any instance which you choose will give you 2/3 of the RAM. So if you go with let's say R6G large instance, then it will give you around 10.5 GB for your working set and indexes. 1/3 of the memory is reserved by DocumentDB for its own purpose. And on the backups, backup cannot be disabled. One copy of the backup is included with the DocumentDB pricing, and you can define backup window to trigger the backups at specific time. It may take up to 5 minutes for taking the backup of the live database. Let's look at some of the ways to connect to DocumentDB and best practices around that. So in DocumentDB, we have been provided with instance endpoint for each of the instance we have in the cluster. We can use these endpoints to connect to a specific instance. These are available to use, but it's not a widespread practice to use it. So unless there is a strong reason to use an instance endpoint, we should avoid using it and rather use a cluster endpoint, which I'm going to talk about it. But there are definitely some use cases for instance endpoint as well, where you want to have one particular instance stored for reserved for a specific work and do not want to pollute the cache for all the other instances. In such case, you can use instance endpoint. So there is also a cluster endpoint, right? The cluster endpoint always points to the primary instance, and it is recommended practice to use the cluster endpoint. It gives you an advantage that you do not need to worry about which is the primary instance. If a primary instance fails, another instance becomes primary, then your cluster endpoint will automatically be updated to point to the primary. So you can always be sure that you'll be connecting to primary instance. Is there any question, Chris?
Yeah, Siddharth, as we are talking through cluster
Mhm.
endpoint and instance endpoints, there's a question from one of the users, Sandeep Sharma, is asking
Mhm.
what would be the use case for using instance endpoint in DocumentDB?
Instance endpoint, as I mentioned, let's say we have a task
Hmm.
which which run once a month, right? And it
Okay.
creates it accesses the data which is not very frequently used, right? So if it uses the cluster endpoint, it's gonna pollute the cache for all of the instances which we have. So rather than
Okay.
doing this, what we can do is we can dedicate one specific instance where this
Mhm.
particular application connect to that instance and just use the cache from that particular instance and not pollute the cache for any other one. And we'll
Okay.
talk about why that is important. It has a lot of implication on the question on IOPS and the cost associated with as well. I think there was a question as well which we are gonna look into in some time now.
The IO cost one. Yeah. Yeah.
Yeah,
All right. Yeah.
IOPS one.
Yeah.
Yeah, and while we just have this pause here, I just wanted to make sure I wanted to address this question real quick. I know we were having a bit of a conversation in the back end. Does AWS Graviton 2 processor support memory encryption? That's not really in the realm of DocumentDB, but as best as we're able to surmise, it looks like there is memory encryption. If Arun, you're able to sort of elaborate on that.
Yeah. So yes. So I think that's not directly for the DocumentDB, but yeah, Graviton 2 processor supports memory encryption, and I think it supports always on 256 bit encryption. And if the question is around, and if at all you are also looking to know if DocumentDB supports encryption of the data in transit or over the network, then DocumentDB also do support TLS, which is security over the or transport layer security, and which is enabled by default in DocumentDB. So yes, so both of them. So Graviton supports encryption in memory, which is Graviton as a processor, and DocumentDB supports TLS encryption.
Cool.
And
So encryption all around. Everybody's happy. Good.
Yeah, thanks, Arun. Um, okay, now coming back to the point of the reader endpoints, we have the reader endpoints, which helps us round robin the read request to all the read replicas. It's again, the reader endpoints like instance endpoints are available, but again, it is not a popular practice to use it. What we should do is we should use the cluster endpoint in replica set emulation mode. That is the recommended practice. But reader endpoints also have their importance when you want to connect to the secondary cluster in a global cluster. So best practice is to always use the cluster endpoint and use replica set emulation if you want the specific reads. So when you connect to a cluster endpoint using replica set mode, you can always use the built-in read preference capabilities of the driver. Arun showed in earlier in the code that how it looks like, right? So the advantage of connecting as a replica set is that it enables your application to discover the cluster topology automatically. Even when if instances are added or removed from the cluster, you can use your cluster more efficiently by routing read requests to your replica instances, and you even if those are added at the fly, right? And this increases the overall resources in your cluster which are available to work for uh, your application. So we recommend connecting as a replica set as a best practice. On the connection limit, instance type determines the connection and the cursor limits which we have. A larger instance which DocumentDB support up to it supports up to 30,000 concurrent connection. The limit scales with the instance type you choose, and there are some reasons why we can uh, hit the upper size of this limit, because sometimes the driver can make poor choices about the connection pooling and can create many connections. You can have like containerized application, and you can deploy it on scale, but if there are and you can lose track of it, and if there is buggy code which are not closing the connection properly, then you can reach that towards the limit of this connection. This is one of the limit which we should monitor, and we'll touch upon this, what are the metrics we should monitor and set alarms for it. On the cursor limits, we support 4,500 plus cursors per instance. And the cursor is basically the collection of document which is written in result to your query using the find method execution. So any open and inactive cursors gets repeated eventually by the DocumentDB. But again, it's not a great way to manage those. The good practice is to close cursors from the application which are opening the connections. There are metrics available to monitor as we talked about the connection limit. Similarly, there is a metric for monitoring the number of cursor as well, which can be used to monitor and apply alarms
Yeah.
on that.
Just want to add here one thing. I think somebody had a question how you move data from DocumentDB to data lake, and that's where I gave an example of glue, right? So when you configure a glue job, you get an option to scale the number of nodes, like how much you want to scale the glue job, and essentially you can also enable parallel read. and that's where you also need to provision the right number of connections and the cursor when you want an application to burst parallel connection to DocumentDB. So you might want to choose the right instance size which can support those number of connections to DocumentDB. Yeah.
Yeah, Arun, great use case is that.
Yeah, thank you for that clarification. And we actually did just get a question from Sandeep again. What if I hit the connection or the cursor limit?
So if we are hitting the connection limit, so it's at the right connection, then we need to vertically scale it. But again, we need to make sure that our applications which are connecting are closing the connections properly. Even if we scale it vertically and there is a bug on the application side, then the number whatever we are increasing it to again will uh, we can hit that number again, right? So on application side, we need to make sure that we are closing the connection properly. If it is about the read connections, then we can definitely horizontally scale those, right?
Okay.
But yeah, for write it's vertical scale, for read it's a horizontally scale.
Okay, sounds good.
Yeah, and then since this is so important, you mentioned, Siddharth, we should monitor them. So monitoring it is as
Correct,
simple as a CloudWatch alarm. Is that fair
correct.
to say?
Yes, we can definitely apply CloudWatch alarms on those metrics and get notified or even take the automated action. Even if we want to scale horizontally, we
Hmm.
can we can write automations for that based on those alarms.
Okay. Yeah.
So now let's get to awaited section and how do we optimize cost for DocumentDB. So DocumentDB has four pricing dimensions. The first dimension is the instances, the compute part of it, the EC2 instance, what kind of EC2 instance you choose. The second dimension is the storage, how much data you are going to store. The third dimension is IOPS, and the last is the backup. Right? So on the instance, pricing varies by the instance size, and the pricing precision is per second with minimum of 10 minutes of billing. And as I mentioned earlier, that DocumentDB reserves 1/3 of the RAM for its own services. Then you need to choose the right instance size, which can fit all of your working set, the data and the indexes. So you need to have a instance which has enough RAM to fit this data. And how do you identify this? How do you come to this number? Is that you can monitor a metric called buffer cache hit ratio, right? And using that, we'll touch upon this metric more in the monitoring part. But again, this is the metric which you can monitor. On the storage side, it's charged at 10 cents per GB. DocumentDB automatically scales storage and IOP, so you should remove any data manually which you do not need. So as a best practice, you should delete any data which is not needed. You should remove any unused indexes. So you should have the data which you need, nothing more than that. IOPS is the third dimension, and it is charged at 20 cents for per million IOPS. For read operation, docs up to 8 KB in size results in 1 IO, and for the write, it's 4 KB in size, which results in 1 IO. Uh, if you have fewer IOPS, it will result in better performance as data is served from the cache instead of storage. And it can also be a cheaper operation. So here I'll take the opportunity to address the question which was asked earlier, that if you want to reduce the IOPS, what you should do is that your responses should be served from the cache. So you need to right size your instances to
Mm.
have that data available in the cache. So any storage operation, for any queries, the storage operation needs to be minimized, right? It can increase the latency as well as the cost because of the IOPS. So if you have it in cache, that's faster response, and it can be cheaper as well.
I need a little bell or something that I hear every time I hear the term right sizing, that I can just ring that. I swear to God, I've heard that term more times in the last like 2 weeks than I've heard in my entire life. But just for my own curiosity, because you mentioned something about identifying data that's not being used and so that it can be removed. There's automated processes in place for that. Like you're not expected to manually go through and look for the usage. There should be something that's telling you like, hey, this data is junk, like you never use it and it needs to be jettisoned out of here. Is that understanding correct?
Not necessarily, Chris, because there are indexes because this is the UR data. You need to, only you are the better judge that whether you're going to use that data or not. But for
Right.
indexes, if you create indexes, you have some functions to identify when it was accessed last time. So
Right. I think yes.
based on those.
No, I was just saying that. So yes, so I think index is a good place. You can find out if the indexes are not used, and
Sure.
essentially based on your use case, right? Sometimes there are use cases where we say, okay, we want to have the data in the collection because of the compliance, even if it is not used. So just by somebody not accessing the data does not really say that okay, we can just put a TTL and can delete the data. So
Right.
ideally as a use case, what is required for the application, you need to find out if you can keep the data or if you can delete the data. I think one of the things that I also want to, I think somebody asked, I think Sandeep asked that I was just that he used DocumentDB and IOPS was higher than what was expected. I think there
Yes.
are a lot of improvements that were made in DocumentDB in 3.6 version in terms of the TTL monitor and garbage collection. So I think about the TTL monitor also contributes to IO. So sometimes customer they look at the IO cost and they do not provision the IO cost for running the TTL monitor and also for the garbage collection. So there are a lot of improvements that have been made in 3.6 after 3.6. I think somewhere in 2020 end. So maybe if you want to reconsider doing another TCO for DocumentDB.
Yeah, might be worth another look.
Yeah.
Cool. Thank you for accommodating my question. I was just curious there, but you can feel free to move on.
Thanks, Chris. Thanks, Arun. In interest of time, I'll move. Try to be a bit faster. Okay. So the fourth dimension is the backup. The first copy is available without any cost, and then any additional storage beyond that is 2 cents per GB. It's an incremental backup, right? So to control your cost, you should monitor the amount of storage consumed by continuous backups as well as the manual snapshot that's persist beyond the retention period which you have set for your RPO. And you can remove any manual snapshots when they are no longer needed. Now,
Siddharth, uh,
mhm.
what happens if I remove my cluster? Would my backups stay, or do I need to do something to preserve
So
them?
any manual snapshots you have will be retained even if you remove your cluster. And
Hmm.
I think when you try to delete it, the console also asks you to take one final snapshot, right? So
Hmm.
you can use that just in case if you need to restore the data. I think that option is
Okay.
available. Hmm.
So the
So
automated
as we
snapshots go away, but the manuals stay, right?
Yeah.
yes.
Yeah. Okay.
So
Yeah.
so as we understand the pricing dimension, how do we do the cost optimization? So when we create document DB cluster, we have option to create it with a single instance or multiple instances, and number of instances basically decide the our availability target. We can have one a cluster with one instance and no replicas. It's going to have presence in one availability zone. So that is going to give us an availability target of 2 nines, and recovery time for this setup would be as long as it takes to relaunch an instance, roughly about 8 to 10 minutes. Such a setup is recommended for dev test only, definitely not for production workload. For production workload, minimum instances you need to have is the two nodes, right? And with two nodes in both in the different availability zone, it increases the availability target to 3 nines and also reduces your recovery time to 30 seconds, which is significant improvement from the 8-10 minutes to 30 seconds. Because if one node is unavailable, the second one can the replica can be promoted to primary. uh, Similarly, you can have 3 node cluster which can give a node presence in all the 3 availability zones. That increases your availability target to 4 nines, but it's not going to improve your recovery time beyond 30 seconds. Having more nodes than 3 uh, can help you scale your reads, but again does not improve anything on availability or recovery time. So to optimize the cost, you need to ensure that your cluster is not over provisioned, and you should temporarily stop start as Arun mentioned earlier. I think Gaurav asked the question. So here, this is the screenshot of the console where you can see the option to stop the cluster. So if your cluster is stopped, there is no cost for compute. Storage cost is still applicable because you have data on the storage, but there are no new writes, there are no IOPS, so there will be no charges for IOPS or the backup as well because there is no new data.
But I think but one thing that you need to make sure that it is stopped only for 7 days. So you need to stop
Yeah,
it again after 7 days.
correct. So you can stop up to 7 days. So indexes are a great way to get faster result for your queries. It's much better than scanning the entire collection, which is a lot more compute and IO sensitive. And indexes are stored as like B-tree data structure. This allows for reading, inserting, deleting data in more memory efficient way. But this improvement comes with a trade-off. If you write any new data to the document DB, in addition to modifying the documents in the collection, indexes also needs to be updated, which can impact write latencies and increase IOPS. Right? Because of this overhead, it's recommended to have no more than 5 indexes on your Amazon document DB collection. And you should also keep in mind the index selectivity. Right? If you choose field with high cardinality, such as identity field, which is unique for every document, you increase the index selectivity. Conversely, if you choose a low cardinality field such as a boolean where are only two unique values available, you can retrieve more information than what is needed, which can increase memory usage and possibly more IOPS. So as a rule of thumb, you should target indexes on the field where the typical value frequency is 1% of total collection. So as discussed earlier, you should ensure that indexes fits in memory. That's going to reduce your IOPS and will save you on the cost. You can use index states to determine the index size. Right here, you can see that we are running states, and it can give you the index size. You can use this size to right size your instance, which you need to choose. You can monitor index buffer cache hit ratio metric to identify that how much is being served from cache. Here I think here we are running it on one of the index, the states, and it gives when it was last accessed. So that's probably answered the question which Chris asked, that do we have a mechanism to identify the data which we need to get rid of. So we can use this for indexes and identify it. We can drop any unused indexes wherever possible.
Cool. Awesome. I'm glad to see it.
Yeah. So and to optimize IO cost, as we mentioned, repeatedly, that instance size is very important, and you should increase the cache hit and reduce IOs. Right? And if you are using TTL indexes allows you to set timeout on each of the document, and when document reaches the TTL edge set, it's deleted from the collection. But when it gets deleted, it incur IO cost for deletion of that data. So possible solution for that is to save cost on that is would be you can use rolling collection, example a collection per day, and drop the entire collection once it goes beyond retention period. Right, so that can save you on some of the IO cost. And for storage, right, you should define your purge requirement. You should remove any documents which are not needed beyond retention period, remove unused indexes, remove manual snapshots which are again beyond the retention period. uh, so it's just like optimizing the data which you need and the data which you do not need. Right. Let's look at some of the matrices which you can use to monitor your cluster. Right. So first thing is for monitoring, it is important to have billing alarms. At a minimum, we recommend you should set the two alarms. One is the 50% spend of your 50% spend of your estimated spend, another is the 75%. So this will help you validate if your estimated bill is close to the actual or not. Secondly, you should use cost allocation tags to get the cluster level visibility, to determine how much is spent on the dev cluster versus test, or depends on what kind of tags you have. It can give you per service per department. And the other metrics, instance level metrics, which we have, we repeatedly talked about two matrices, the buffer cache hit ratio and index buffer cache hit ratio. The ideal values for this number, for this matrices, should be above 90%. Right, and you can probably set an alarm if it goes consistently below 80%, because that is an opportunity where you can look at your instances and probably uh, resize it. And then
Uh,
the, sorry, database connection and database cursors, these are the two metrics which you can monitor and set alarms on uh, for if knowing if you are hitting the upper limit. Yeah, I think, and there are some cluster level metrics as well, which you can utilize, right? The database cursor timed out is again one of the metric which you can monitor at the cursor level. I think with this, bro, I'm done pretty
Cool.
much. Yeah.
Cool.
And we do have a question here coming in at the tail end of the presentation today, again from Sandeep. How do you resize storage in DocumentDB?
Yeah, so that's a good thing about DocumentDB. You don't manage, it's fully managed the storage. It automatically scales up as you add more data, and when you, like Siddharth was talking about how you can delete the data, delete the indexes. So as you delete index or you drop a collection, it automatically scales back down. So you only pay for the storage that you consume for your data. So it automatically goes up and it comes back down when you delete the data from it.
Cool. Perfect. Sounds easy enough. Like I said, that is the tail end of today's presentation. So thank you all. I mean, so much information. We barely squeezed it into our 1 hour time slot that we had. Of course, if you do have questions that weren't answered today about DocumentDB or other things, I would recommend going over to repost.aws. It's just an open forum. There's a bunch of experts like the experts that are joining us here today who are active on the site. They can answer your questions, or who knows, somebody's probably already asked it, and you can go ahead and do a keyword search and maybe get the answers that you're seeking there. But thank you all so much for taking the time to join today. I know it's not easy coming up with all this information and being on a live platform like this. If you want to let us know how we did, I will find the link to our survey again. I'll put that into our chat over here. Feel free to give us a grade. And I do read these, so I do want to know what you want to see on the show so we can make more episodes. So please let us know. And then finally, I'm going to post a link to our Splash That page where you can find out what we have coming up down the road. And we usually have the show every 2 weeks, but we're not having the show in 2 weeks because of Holi. So that's going to be celebrated, and all of my colleagues will be off celebrating that. I hope it's a fun time. Hope you all have a blast. But then because of that, we're going to be postponing this to the following 2 weeks, which would be on, looking at the calendar here, March 22nd at 10 a.m. IST. So please keep an eye on that Splash That page. We'll update it. You'll know what the topic is. You can join us then, and I'm sure it'll be fun and exciting. But for now, Gaurav, Arun, Siddharth, thank you so much. Enjoy the rest of your day. I know that it's early there. Anybody that's joining us here in the chat, thank you so much for your time today. I hope that you had a fun time, and we hope to see you again.
Thank you, Chris.
Thanks,
for
Chris.
having-
Thanks, Chris. Thanks. Happy to be here. Thank you.
Take care, all.
Yeah. Too.
Happy cloud computing.